will continue our chapter 5 part B. Recall back in chapter 5 part A, you have statistical analysis for means or confidence interval. So for here, you will have chapter 5 part B, statistical analysis for mean, and we will cover hypothesis testing. What we have in the content, you will have 5.2, 0.3 and 0.4. In 5.2, we will cover introduction to hypothesis testing. What is hypothesis testing? 5.3, you will have hypothesis testing for 1 mu, and for 5.4, you have hypothesis testing 2 mu. Alright, introduction to hypothesis testing. Before we go further, let us recall back chapter 5 part A. In chapter 5 part A, you have confidence interval. What did you do in the confidence interval? We estimate the population using sample. For example, you have a population, you want to estimate the mu. You take a sample from here and then you calculate the x bar. So this x bar is the estimator for the mu. So we covered confidence interval for 1 mu. For the 2 mu independent sample and for the 2 mu dependent sample. Okay, in chapter 5 part B, you will have hypothesis testing. Okay, what we want to do is we want to test our parameter based on the sample, based on the statistic. Okay, in hypothesis testing, also you will have hypothesis testing for 1 mu, hypothesis testing independent sample, and hypothesis testing dependent sample. So the same concept you apply here, which formula you want to use, you also will apply the same concept here, which formula you want to use. So you still need your stat table, page 5 and page 6. Okay, continue. What is hypothesis? Hypothesis is actually a statement, kenyataan, or your initial assumption, your ramalan awal, right? But you don't know the hypothesis is correct or not. That's why you need testing. You need to test your hypothesis. So hypothesis is a method for testing a claim that you made about a parameter using a sample. Okay, in hypothesis testing, there are 3 methods: the conventional method, p-value method, and the confidence interval method. We will look at this one. Alright. So, example. A scientist may decide on the basis of experimental evidence whether drinking coffee increases the risk of blood pressure in human. So the hypothesis is drinking coffee increases the risk of blood pressure in human. But this is your initial assumption. You don't know your hypothesis is correct or not. You have to test. Is it correct drinking coffee increases the risk of blood pressure in human? You have to test. That's why you need hypothesis testing. Second example. An engineer might have to decide on the basis of sample data either there is a difference between the accuracy of 2 kinds of devices or not. So the hypothesis, the initial assumption, state that there is a difference between the accuracy. Is it correct? Is it correct, your hypothesis? Is it correct there is a difference between the accuracy? You have to test. So that's why the hypothesis testing come in. So a simple example. For example, you see a boy from behind and then you say that, wow, that boy is handsome. From back, from behind, you don't know. Okay, this is your hypothesis. This is your initial assumption. You said that, oh, that boy is handsome, but you don't know. What you do is you have to test. Is it correct that boy is handsome? What did you do? You go in front of that boy and you look at his face. Oh, then you decide your hypothesis is correct or not. Okay, that is the example for the hypothesis testing. Okay, in hypothesis testing, there are procedures. We want to test the hypothesis, right? So there are several procedures. There are step 1. Step number 1, you need to have your hypothesis. Okay, in order for you to have your hypothesis, you need to have the null hypothesis. We call it as H null. And then you will have alternative hypothesis H1. Alright, for step number 2, you have to calculate the test statistic. Step number 3, determine the critical value based on your alpha. Step number 4, make a decision. Step number 5, draw a conclusion. So, step number 2, number 3, and number 4 will be your evidence to test this. Step number 1. Step number 5 will the conclusion. Alright, so now let's summarize a little bit the hypothesis testing procedure. As stated in the slide, there are 5 steps to test your hypothesis. So step number 1, we call it as formulate the hypothesis. In formulating the hypothesis, your initial assumption, you must have 2 hypotheses. First hypothesis, denoted by H null, we call it as null hypothesis. Okay, in null hypothesis, the symbol must have equal sign. It's either equal, greater than and equal, or less than and equal. And then, if you have null hypothesis, you will have H1, what we call it as alternative hypothesis. It's the opposite of the null hypothesis, where the symbol is unequal, less than, and greater than. In formulating your hypothesis, there are 3 types of hypothesis that you need to know. First one, we call it as two-tailed hypothesis. Two-tailed hypothesis. How you want to know that your hypothesis is two-tailed? Look at the H1 symbol. If the H1 symbol is not equal and the H null symbols is equal, this one is two-tailed hypothesis, where the alpha significant level need to divide by 2. Okay, number 2, you will have one tail right. Okay, how do you want to know one tail right? Look at the H1. If the H1 is greater than and the H null is less than and equal, your significant level alpha, leave it alone. Do not divide by 2. And number 3, you will have one tail left. How do you want to know that your hypothesis is one tail left? Look at the H1. If H1 is less than and then your H null is greater than and equal, then your significant level alpha cannot be divided by 2. So you have to remember these 3 types of hypothesis. Okay, in order for you to write down your hypothesis, you must have H null, H1, double dot here, and then here must be your population. For example, mu, symbol, and then you must have sign. It's either equal or not equal, or depends on the equation. And you must have the mu naught here. Mu naught here must be a number, a value. So don't worry, we'll look at the example. Okay, next, after you formulate your hypothesis, step number 2 is calculate the test statistic. You want to test your hypothesis now, so you have the formula. The formula to calculate the hypothesis you can get from your stat table, page 5 and page 6. It's either t-test or the z-test. Okay, Next, step number 3. After you calculate your test statistic, we want to set the critical region. So critical region, we have 3 hypotheses, right? 3 types of hypotheses. So the first one is two-tail. Critical region for two-tail hypothesis. So let's say you have a normal distribution here. Okay, two-tail hypothesis means that you have two shaded region, left and right. So this shaded region, we call it as rejection region. And the non-shaded region, we call it as acceptance region. Okay, here is your 1 minus alpha located at. So here is your alpha over 2. Here is your alpha over 2. Okay, how about the boundary that separate the acceptance region and the rejection region? We call it as critical value. CV is critical value. You will get this critical value from your stat table also. Okay, when you want to put the critical value on the left side, you must put the negative sign, and the right side you must put the positive sign. So this one is for the two tail. And number 2, you will have one tail right. Okay, for the one tail right, example, you have a normal distribution. One tail right, it will be on the right shaded region. This one is your rejection region. This one is your acceptance region. Critical value will be here and put the positive sign. And then the last one tail left. For one tail left, so you have a normal distribution. Why normal distribution? Because of continuous data. Shaded region on the left. Okay, this one is your acceptance region. This one is your rejection region. Right? This is the critical value. So when you have one tail left, critical value must have negative sign. So note that this critical value can find from the stat table. Okay, so next step, after you have found your critical region and your critical value, you want to decide. You will go for step number 4, your decision. How you want to make decision? In decision, we want to make a decision based on the H null. It's either you reject or you do not reject H null. Okay, how you want to know you reject or you do not reject H null? First, look at test statistic value in step 2. In step 2, you have calculate your test statistic. So look at the value of the test statistic in step 2. Number 2, if the value falls into rejection region in your step 3, what you have to do is you have to reject H null. So in step number 4, we talk about H null, the shaded region. If the value in the step 2 falls into rejection region or your shaded region, you must reject H null. That is your decision. And step number 5, we call it as conclusion. So you want to conclude now your hypothesis. Okay, so conclusion, refer back to our hypothesis. Refer back to step 1. It's either you accept your hypothesis or you reject your hypothesis. And normally we will start with at alpha ... we have enough or not enough evidence to support claim. Okay, so where is the evidence? Evidence is step number 2 until step number 4. Okay, this is the theory, the procedure to conduct your hypothesis testing. So you must remember these 5 steps, because from now on, chapter 5, chapter 6 and chapter 7, you will repeat the same step. Okay, so now let's look at the example, how to conduct hypothesis testing for population. Try to do example to formulate the hypothesis. If you're wrong formulating your hypothesis, all your hypothesis testing will be wrong. So now state the null and alternative hypothesis for each conjecture. A researcher thinks that if expectant mothers use vitamin pills, the birth weight of the babies will increase. In previous report, the average birth weight of the babies without consumption of vitamin pills is 3 kilograms. So in the illustration just now, if you want to write down your hypothesis, you must have H null double dot, H1 double dot. Here will be your theta, here will be your theta, the notation of the parameter. Okay, here will be symbol. The symbol, it can be equals, greater than or less than. Same goes to here, it can be unequal, greater than or less than. So here this part is theta naught. Theta naught here is a value, a number. So look at the question. A researcher thinks the weight of the baby will increase. So increase, the symbol is greater than. In previous report, this one is population. Average birth, so mu. Baby's weight is 3 kilogram. Right, so H null H1. So greater than, is it there is symbol equal? No. So if there is no equal sign symbol, it will be H1. So greater than. So what is the symbol here? Mu. So mu. If H1 greater than, H null is less than and equal, opposite. So this part must be number. So this mu is equals to 3. So here will be your claim. So this is how you write down hypothesis. Okay, let's look at next example. An engineer hypothesized that the mean number of defects can be decreased in a manufacturing process of compact discs by using robot instead of human for certain tasks. It is known that the mean number of defective discs by human is 18. So the keyword here is decrease. So decrease is less than. And then here we take, it is known that. So it is a population. Mean number mu is equals to 18. Alright, so you want to write down H null or H1 first, it's up to you. Because of the symbol is less than, it will be H1. So the symbol here is mu. Notation is mu. So if H1 less than, H null is greater than. So the number here is 18. Okay, next look at another example. A psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the test without playing soft music was 73. So here, the psychologist feels that playing soft music during the test will change. And then you don't know will be higher or lower. So the symbol here is either equal or not equal. In the past, refer to population. Mean, the notation is mu because of population. So the mu is equals to the 73. So how to write down your hypothesis? H null, H1. You want to write down H null or H1 first? It's up to you. Okay, this is the symbol. So the notation is mu. The symbol is equals and unequal. The value for the mu is 73. That's it. Okay, I hope you understand how to formulate the hypothesis. So next we will look at the example for hypothesis testing one population mean.